Today we're going to be looking at the 2018 US Open Gold Question Talent Show. So in this question, Farmer John's and cows are going to the fair, and each one is going to have a W, weight, and a talent T. So what's going to happen is Farmer John is going to need to A, bring a group of at least weight W, and B, need to basically have the largest ratio of talent over weight. So what we want to do is we want to give the largest possible ratio that he can achieve. So the main algorithm we're going to be using to solve this question is going to be DP, or more specifically knapsack. So this question is a pretty stereotypical example of something that could become a knapsack question. So what we're actually going to do is we're going to assume that we're going to have a 2D DP. And the first dimension is going to be from 1 to n plus 1, or 0 to n. But what we're basically going to do is we're going to assume that if we're on cow I, so this is going to be our first dimension here, if we are on cow I, all of our values are only going to include cows from 1 to I. So we're going to be finding the minimum possible weight, but when we're at position I, it's only going to include cows that are from 1 to I. So the second dimension is going to be the talent, and this is just going to be like a stereotypical knapsack. So we're going to have from 0 to the maximum talent, which if you think about it is just going to be the total talent of all of the cows together, because we can't create any more talent than that. And what we're going to do is we're just going to loop through the cow, the first dimension, and then we're going to loop through the second dimension. And what we're going to do is we're going to do a transition that's going to look like dpij is going to be the minimum, because we're trying to find the minimum weight in order to achieve the best ratio of either dpi minus 1, j, and what this means is we're not going to include the cow. So you can basically assume that if I'm at the position ij, then I'm going to have cows, it doesn't matter how many cows I have, but I'm going to have cows up to the ith cow from 1 to I that are going to have a total talent of j and a minimum amount of weight in the value. So what we're going to assume here is if we just take dpi minus 1j, that basically just means we're going to take the previous value and we're simply just going to be not including the current cow I. So we're just going to find whatever was the value not including cow I, or we're going to include cow I. So we have two different options, include or not. And if we're going to include it, first of all, we're going to have an if. So the if is going to look something like, if j is greater than the talent of our current cow, and the reason is because we're going to be subtracting it. I'll show you this here. And so we're going to have dpi minus 1 again. And then we're going to include the talent of our current cow. So it's going to be j minus, let's just say cows I T, and this is just going to mean we're going to have this current talent, so we're going to go back and we're just going to assume the minimum weight of dpi minus 1 and then the talent minus our current talent, and then we're going to add our current talent and add our weight. So we're going to do this plus weight. And we're basically going to use this transition, and then at the very end, we're just going to loop through, and we're going to find the best value of dpn, and then we're going to loop through here to find the best value of j. So let's go look at the code for this question. So I've set up the program a bit here. We have long, n, and w, and then I've created the value of cows as a vector of pairs. And then we have our INF value, which is just going to be max. And then the other thing I've done is I've defined f and s as first and second. So anytime you see .f or .s, it just means .first and .second. So over here, the first thing I'm going to do is I'm going to read in the input. So for this question, I'm going to have a value called max t, which is going to be the maximum possible talent, because since we're doing a knapsack problem, I'm going to need to know how big this second dimension is. And the maximum talent level is just the total talent level of all of the cows combined. So I'm just going to create that value. And then I'm going to create my dp with the size n plus 1 for the first dimension, and then max t plus 1 for the second dimension. So I'm going to set up the dp by doing answer as 0, and then dp 0, 0 as 0. And then I'm going to loop through and do a regular knapsack. So we're going to have for I from 1 to n, and then for j from 0 to max t. And then what we're going to do is we're going to check the two different constraints. So if j is greater than or equal to cows is, then we're going to create dpij, and we're going to do exactly what we described earlier, where we're going to make it the minimum of I minus 1j, or I minus 1j minus cows i.s, which just means we're adding this current cow to our current lineup. And then we're going to add the weight of the cow. And then if the current amount of talent, j, isn't enough, then we're just going to make it the value of dp I minus 1j. And then at the very end, we're just going to find the maximum value by looping through all of the values of max t. And then we're basically going to check if the weight of that value is greater than or equal to w, then it's going to be the maximum of the answer, and then we're going to find the ratio. And then at the very end, we're just going to return our answer. And that's the end of our program.